At first glance, Unreal Engine's blueprints and C++ can feel like they belong to completely different universes. One is visual, fast, almost playful. The other is technical, strict, and full of mysterious syntax. But step by step, we are learning how these worlds connect and how you can crack the code to build confidence with both. In the first 3 videos, we laid the foundation, C++ basics, Visual Studio setup, and the core ideas behind object-oriented programming in Unreal. Now it's time to take a real step forward. In this video, we'll start exploring the first-person shooter project that comes with Unreal Engine. You'll begin to understand how the engine's API works by digging directly into the header files. We'll break down how this code connects to blueprints, how instances behave, and what's really happening in the event graph. We'll go line by line until everything makes sense, or at least almost everything. Before we get started, support this channel with a like, subscribe, and hit the bell so you don't miss new tutorials and strategies to grow your game dev career. If you're serious about getting into this industry, head over to woolen.com and watch my free training. It's built for people like you who are building their dreams after hours or feeling stuck in a career that doesn't excite them anymore. And if you've been stuck for more than 6 months without real progress, without finding job opportunities, it's probably time we talk. Book a Zoom call and let's see how the Game Creator Accelerator, my lifetime mentorship program, can help you finally build the path to the career in game development you wish, with the guidance and support you've been missing. Now let's get started. The first thing we're going to do is to open the MyShooterFPS. This was the same project that we created on the first video of this series. And don't worry about the fact that we are using Unreal 5.4. Even for the most recent at this moment, which is Unreal 5.6, the principles that we present here, that we show you here, applies for any version of Unreal. Let's begin by understanding the structure of the files that we created, that Unreal automatically creates when we select a C++ project. Inside the all content, you have, well, not inside the content, but inside of all, you have another folder that is called the C++ classes. You can click on it and then open it again, and you have these classes that we are going to talk in a second. But I want to have a perspective from Visual Studio. To have it, you just have to click in any of these classes. So let's double click and Visual Studio start prompting up. In the folder Engine, you will find Unreal Engine source code that we usually don't touch, though it is possible, depending on the deep features that you need in the future, to control or enable for particular things that you need for your project. As for the engine folder, we also have the visualizers, and the visualizers folder containing NatBeast files, which at the same time contains an XML configuration for managing objects and data in Visual Studio. Again, this is something that we are not going to play with. One of the most essential folders is the folder called Games. And in Games, you have another subfolder which has the name of your project. The external dependencies folders contains header folders that you will need to write the game code, and this is automatically generated by the IntelliSense. It's nothing that you are going to touch at this second. I'm sorry that I'm going to mention all the things that you are not going to touch, but it's just to give you context. The importance of this folder and their headers is that it will help you with the IntelliSense when you're writing the code in C++. Then we have the config subfolder, where are the initial configurations files for your project. In previous versions of Unreal, previous to 5.4, this folder was inside the source folder, which is this folder. And now we reach the source folder, which is the meat of your project in C++. All the generated C++ code, source code, will be placed in this subfolder of MyShooterFPS. And as you can notice, it has the same name as your project. Now I want to take a second to explain a game cycle. To do that, I'll go back to our project in Unreal, open the subfolder content. Inside first person, you have another subfolder called blueprints, and let's open any of these blueprints. Don't worry that we're going to explain what blueprints are later on. And inside this blueprint, click where it says Open Full Blueprint Editor. To present you a quick context about blueprints, imagine that they are actors, things that you're going to put on your scene that responds to components, which you can see here to the left, and makes some actions based on these components. These actors are associated with classes and subclasses that will allow them to do different type of things depending on the parent class. In blueprints, you have one option which are the event graph that you can also open it here. In this space, you can program different actions using boxes that you are going to connect one after another. These boxes are called nodes. And to explain the game cycle, I want to use some nodes that we can represent graphically here on the event graph. Inside the event graph, right-click and look for Event Begin Play. This one here. Right-click again and look for the event Tick. And finally, right-click again and look for the event and Play. Most of the games have three key stages that run behind the scenes: the game initialization, the game loop, and the game end. And the cool thing is Unreal Engine takes care of all of these stages. The game initialization is where everything begins, when the game is launched. Unreal sets things up at this point. It configures the display, loads content, spawns your characters or any other props, and gets the world ready to play. It's like setting the stage before the show starts. Then we have the game loop. This is the heartbeat of your game, the moment-to-moment gameplay. Every frame, Unreal listens for the player's input, updates the world, and redraws the scene. Think that the animation is moving, bullets are flying, environment is shifting. That all happens here. Each actor in Unreal has two special functions that are only called once. They are first the construction script, which is inside the construction script, and the other is inside the event graph, which is called the event begin play. They are both called just once when the object is spawned into a scene. And it's the perfect place to set up tasks when the object is created. Inside the game loop, we also have this event tick. And this event is called every single frame. This is where the magic happens. The game logic, character controls, effects, and anything that updates constantly during the gameplay. To close the cycle, we have the game end. This is when the game wraps up. Whether it's a win, a loss, or just that you quit the game. The engine cleans things up, destroying actors, freeing memory, closing network connections. Each actor has an end play, which is this event you have here at the bottom. And it will be triggered when this event happens. That's your chance to clean up anything the actors was doing or using. I also want to add that not all these events are mandatory for actor classes. You will use them as you need them. Now you see the events here, and I want to go back to C++ to see these events as well, but defined in code. Back to the first person map. Inside the My Shooter FPS, I'm going to open my Shooter FPS character. Allow me to clean some space here. I want the Shooter FPS just for a second alone. Now I want to visit the header file, and you can see that we only have the function for the event begin play, but we don't have it for tick or end play. This event that you are controlling on C++ on Visual Studio, it is the same event that you can have in the blueprint called event begin play. The power of combining C++ and blueprints is precisely why Unreal is so powerful in terms of programming. But keep in mind that you can create any game that you want only using blueprints. It is not our goal to go only for blueprints, but to learn how to use in combination C++ and blueprint. Good programmers, professionals, have the ability to handle the two worlds at the same time and learn how to use them in the most effective way. Now let's get you more familiar with the source code, and we are going to start using the myShooterFPSCharacter.h. Remember that the header file contains declarations. Example, it contains class definition, functions, prototypes, etc. On the other side, the implementation file, or the CPP, contains the implementation of these variables, of these definitions, of these functions. The code in the header file can be divided into 4 parts. First one, the definition of the class, which is associated with the name of the class that we assigned. Then the definition of the class variables. Then the declaration of the class member functions, and finally the declaration of the functions for setting up inputs and the getter functions. This section from the line, in my case from 10 to 15, defines some Unreal classes and structs that will be used in this module. Because they are declared in the header, you need to do something called the forward implementation or the forward declaration. That is telling the compiler that I'm going to use this class and I'll initialize it later. You will initialize it, in fact, on the implementation file. But for the moment, just allow me to declare it in the header. A second ago, my Visual Studio crashed and I have to reopen the project. So first off, you can see that we have this red underline that sometimes it is generated, but that doesn't mean that you have an error in your code. Yes, I know it's a bit confusing, but if you go to Build and select the option of Rebuild My Shooter FPS, you will see at the end that you have 12 succeed, 0 failed, 0 skipped. So everything is working correctly. Back to the talk about the forward declaration. Here you can have a clear example. The mesh 1P. It is a uskeletal mesh with a pointer to this class. And in that, at the top, you have the UI skeletal mesh component where you forward declare it before using it here. Now let's go to the line 17, which is the declare log category extern. This is a macro that is provided by Unreal to declare custom log category that you can use with the macro UE log for printing output log in the editor. Then we have the U class. This is a macro provided by Unreal Engine that marks the C++ class as a U class. U class meaning that the U is coming from Unreal. And this means that it integrates with Unreal's reflection system, allowing to be used in things like the blueprints, serializations, and the editor. When we talk about the reflection system of Unreal, we refer to this is a way for the engine to see and interact with your C++ class, especially when we are talking about classes, variables, and functions, even if they are written and compiled in C++. Inside the U class, we have this parameter, which is config equals game. The config equals game part tells Unreal that this class can load and save properties from the default game.ini or ini, I don't know how to pronounce it, which is the configuration file. That file is located on the subfolder config default game.ini. You can add different types of configurations in these files before launching the project. And I remember that in previous versions of previous projects I worked on, for example, the case of multiplayer, I have to configure some new variables for these ini files. But in this case, we are not going to touch it. Now we're getting inside the class. The first part is this declaration, where the myShooterFPS characters inherits from the class A character. The A prefix is required by the engine's coding standards. All children classes from A actor will have the prefix A. The next line in order is the generated body. Without the generated body, your class won't be fully recognized by the engine's systems, and you'll likely run into compilations or runtime issues. In Unreal Engine C++ projects, generated body is a macro that plays a crucial role in integrating your class with the Unreal Engine's reflection system. When you declare a class with UCLASS, UStruct, or UInterface, you must include the generated body inside the class definition. The generated body enables features like the reflection, so the engine can inspect properties and functions at runtime, serialization for saving and loading object data, blueprint integration, allowing you to your C++ class to be used in Unreal's visual scripting system, and the networking support for replicating properties and functions across clients and servers. We're talking about multiplayer. But in simple terms, you cannot forget to add this line or the world will go to hell, which means that the compiler won't like it at all. Then we have the declaration of private variables. I know that you don't say explicitly here that the next variables will be private. You don't have to say it. By default, as soon as you don't add another type like public, protected, public, etc., they will assume, the compiler in C++ or Unreal assume that this section will be private. But if you want to be even more explicit, you can literally write private here. You can see though that you have the variables and you have the UPROPERTY on the top. All of them start with the UPROPERTY because this refers to the properties that will be declared in Unreal related to this variable that are under the line of UPROPERTY. Don't worry, we'll get to these details in a second. And the other thing is the use of the use. That means that they are classes that inherits from the Unreal classes. Like in this case, USKeletal Mesh Component. This is a class that belongs to Unreal. The same for UCamera component, UInput action, and again the UInput action. The next part is this public section where we have the My Shooter FPS character, the same name for the class. Why? Because this is the constructor that we cover on the previous video of this playlist. And because it is a constructor, it has to be public. I know we've been digging into a lot of technical details, so take a quick breather. Head over to woolen.com and check out my free training. It's designed to help you rethink the way you learned, build momentum, and start uncovering real opportunities in game development, all while building your independence as a creator. If you are serious about making this your future, what are you waiting for? Take a deep breath and let's keep going. Then we have the protected section with the function of virtual void begin play. This function is the one that I presented some minutes ago in the blueprint directly. And this function is called during the object creation, just after the constructor. As we mentioned in the previous video of the series, the virtual keyword means that this function can be overridden by its subclasses. And that's exactly what we want to do. If you want to inspect some of these functions or their origin in Unreal, you can just move the mouse over it and select on this pop-up the search online. It presents you with something like this, and then you can see where this function is, the origin, to what class it is assigned, in this case the A actor. And you can click here and go to the details related to that event. Previously, we covered the public and the private sections in a class, but we haven't talked about the protected. When you declare something as protected, it means that it can be accessed by the class itself. It can be accessed by any class that inherits from it, a class that is derived the class, but it cannot be accessed from outside the class hierarchy, like from unrelated functions or objects. In some way, the protected is a middle ground between private and public. A little bit down, we have another sections for public and protected that are handling the actions they input from the player. We first have a class, we have a variable called lookAction of the type of the class uInputAction, which is the class that handles all the inputs from the keyboard or from the gamepad. And then we have the protected section with the functions of move and look. Worth to mention is this fInputAction, which is a struct. And we haven't talked about the structs in this series. In C++, a struct, a short for a structure, by the way, is a user-defined data type that lets you group variables of different types under a single name. Imagine that it is like a lightweight version of a class. The key idea, in simple terms, is essentially that the struct is the same as a class, except that its members are public by default, whereas the class members are private by default. In another protected section, we have the setup player input component, which will define the controller, let's say, for control the player. And finally, we have this public section. And this section that we always place at the end of the header is related to what we call the getters. Getters are used to obtain information from a variable without being able to change it. For example, let's say that we have the getMesh1p and it's returning the mesh1p. Let's say that we want to provide the variable in a way that will be public, but we don't want other developer to change this variable. We just want to present what it has, the properties, even called the methods or the functions, but we don't want that developer to change the variable. Then is when we're going to use the getters. And the structure is pretty simple. You first declare the type that is exactly the type of this mesh1p that we define at the beginning as a uSkeletal mesh component. Then it's going to be a uSkeletal mesh component, and we called a function, which is the getMesh1p. And the result or the return of that function is a const that is the mesh1p, the same that we established, that we created here on the top. But the only difference is, remember that on the top we declare this as a private variable. In this case, we are providing the variable. We're saying you can check the variable, you can call the properties, call some methods probably that are also public, but you cannot change the variable. That is the main concept behind a getter. Now that we give a quick look to the header file, I want to talk about this declaration, the UPROPERTY Declaration. When you work with a variable that you declare in C++ and you want to use this variable as well in Unreal, you have to define where you want this variable to be accessible. There are three spaces where you can have access to or not to this variable. The first one is inside the blueprint. So let me take the same BP first person that we opened a moment ago. And you can see that when you go to the class setting, you can define what is the parent class that this blueprint is using. In my case, is my shooter FPS character, which is exactly this same class. Look that it only separates by the caps the name inside Unreal. Here we have my shooter FPS character, and in Real we have my shooter FPS character. That means that this blueprint is using the code that is assigned on my shooter FPS character header and the implementation file. When you use the UPROPERTY declaration, you will be able to control these variables on this environment, which is called the defaults or the archetypes or class defaults. You can access it as well if you define an instance of that blueprint inside your scene. This will be an instance which it is presented in the outliner. Or the third option, that you can access that variable inside the event graph. Where and how we present this variable is the goal of using the UPROPERTY declaration. Let's take one of these variables, for example, the mesh1p. And I want to present this table I created to help you understand a bit easier how the U property works. In this table, we have where the U property will be presented. For example, in the defaults, like in the blueprint or the original class, in the instance, which is an actor inside your scene, or the event graph that is also inside the blueprint. If we declare a variable which is visible anywhere, as it is the case of the mesh1p, we're saying that will be visible in defaults and as an instance, and also that variable will be only read-only. That variable will be read-only. But we can also control how this variable will be used in the event graph by saying, well, I can use it blueprint read-only, or I can use blueprint read and write. Visible anywhere covers the defaults and the instance. But let's say that you want to give access only to defaults. Then you will use the visible defaults only. So instead of using visible anywhere, you will declare visible defaults only. Similar, if you want only to be used for instance, then you will write visible instance only instead of visible anywhere. On the other side, if you want to write as well to set these variables inside Unreal, you can then use the edit anywhere, which allows you to edit in the defaults or the instance. You can use the edit defaults only, which apply only for the defaults, and as you can imagine, edits instance only that will change only in the instance. And again, event graph is independent of this setting. So you can define read only or read and write and independently control the event graph access by blueprint read only or blueprint read write. Then we have the private access, and you use this metadata. And you define it just like this. Meta equals to allow private access equals true. Look that we have it here on the top. This metadata is very important because you might have a private variable just like this one in mesh1p that you want to be private when you are working in C++, while you are coding directly in C++. But you, at the same time, might want this variable to not be private when you are working in Unreal. This is why we declare the allow private access equal true. That provides you the access to this variable that is private in C++, but you can access it on Unreal directly. If you don't want this variable to be accessed in Unreal as well, you don't have to write this section. And finally, we have the category where you can define a category name where this variable will be part of, and is a way to be more ordered when you're working in blueprints or in Unreal in general. We covered a lot today, and I know this might feel like a lot to process. That's totally okay. Take your time, rewatch if needed, and let it sink in. If you found this helpful, give the video a like, subscribe, and drop a comment to support the channel. I read them all, and they help guide the future content. In the next video, we'll dive even deeper into the core of C++ files created with the first-person shooter project. We'll explore the implementations files and how they connect and communicate with blueprints in Unreal. And don't forget, visit woolon.com and access my free training to start transforming your learning process, building real momentum, and opening doors in the gaming industry. There is a game in your mind that the world deserves and is waiting to play. So keep creating, keep sharing, and keep dreaming big. I'll see you soon, my fellow creators.